Now, what I'm going to do today is talk about the coefficient of determination. Again, this is on how you are going to interpret your data. You do know how to use your class pad to find the regression line, the equation of the regression line. You should know how to find R, which is the coefficient of determination, coefficient of correlation, and then we're going to talk about the coefficient of determination, which is R squared. It's straight R, but it's R square of R. All right? So what I'm going to do today is basically make sure that you understand what is coefficient of determination, and you should be able to derive the coefficient of determination R squared from R, and then use your class pad to determine R squared and interpret that. Now, interpreting, I'll give you a standard sentence that you can use, but you must be flexible and vary the sentence according to situation. All right? So now, if you could recall, we have actually learned how to use your class pad to come up with the linear regression line equation with y equals mx plus c, and then we know R. Now we're going to concentrate on R squared. All right? We know R is the Pearson correlation coefficient. It's a measure of how closely the relationship between two variables approximate a linear relationship. Now, since R is between -1 and 1, so when we have R squared, what happened? All right, let's think about that. Keep that in mind. We'll talk about that in a few minutes. Now, -1 indicates a perfect negative linear relationship, and 1 represents a positive linear relationship. All right? So now, what if we square this? What would happen? When we square this, basically the range is between 0 to 1, because -1 squared will give us +1, and 0 squared will give you 0. Whatever negative square will give you positive number. So the range of R squared this time is between 0 and 1. If you've got anything other than 0 and 1, something is incorrect. All right? So coefficient of determination R squared tell us how well the regression line actually represents the data. It is a square of the coefficient correlation, and it's usually converted to a percentage. All right? So you've got 4 decimal places, and when you quote the percentage, it's 2 decimal places. All right? Now, this sentence is important because generally you're using this sentence to explain the R square. R square is a percentage or the proportion of the variation in the response variable that is explained by the explanatory variable. The next slide, I'll give you the standard clause that you could use. All right. Now, give you a couple of minutes to write that down while I take a sip of water. All right. Remember, 3 to 4 decimal places, and when you code it in percentages, give you 2 decimal places. So generally 4. All right. The next one coming out is the important one. Here. Yep. Sorry. Of course. Ooh. That one. All right. So remember, R squared is a percentage or proportion of the variation in the response variable that is explained by the explanatory variable. All right, the next bit, which is this sentence that I really want. So when interpreting the coefficient of determination, a general sentence can be used. The general sentence, like 20% or 90% or 78%, which is R squared times 100%, converting the percentage of the variation in the response or dependent variable. So for example, yesterday, the variation in the sale of ice cream. can be explained by the variation in the explanatory or independent variable, can be explained by the noon temperature. So something like this. If you think about the ice cream sale and the noon temperature, so you can say 98%, it depends on what R squared we get, of the variation in the sale of the ice cream can be explained by the variation in the noon temperature. All right? So as R squared value gets higher, the relationship between the variables gets stronger. The regression line becomes more appropriate model for the data. So I know when I was using a lot of regression, I actually look at R squared rather than R. And then the R squared value does not tell us the direction, positive or negative, because R will tell us, but not R squared. R will not tell us whether it's positive or negative. It only informs us how the variation in the two variables can be explained. So that sentence here is quite important. So from that sentence, you can say that there's as R squared it's larger, the relationship between the variables gets stronger. And generally, I have seen last few years this sort of question came up. What does R squared explain? All right. Now, so that's an example here. If R squared was 0.8, then we can state that 80% of the variation in the dependent variable can be explained by the variation in the independent variable. Or alternatively, that 20% of the variation in the independent variable is not explained by the variation in the independent variable. I'd rather use the first sentence rather than second, because we are quoting R squared, we might as well use R squared rather than 100 minus R squared. All right? Are you all okay with that? If you are, let's go on to the first example that I've given you on your worksheet. If you would be able to put it in ClassPad, and let's talk about the R squared in a few minutes. You see, part B is asking you to interpret the coefficient of determination. And then you need to be able to state the regression line that models this data. And we'll talk about do you think that the model is appropriate? You need to justify the answer. So let's actually put that in your ClassPad first. You've got it in front of you now. Makes life a little bit easier. The question asks you correct to 3 decimal places, so make sure that you do that. It depends on questions. Some question will ask you, some examiners will want you to go up to 4 decimal places. And if they don't specify, use 4. And then you can convert it to percentage. All of you comfortable in using the calculator, the ClassPad? Once you put that in, this is what I have. I have actually got R squared of 0.85666266. Agree with me? Yeah? So if you agree with me, we'll move on to answering the question. So here, assuming that the minimum temperature is explanatory variable, calculate the coefficient of the determination correct in 3 places. Right? So, answering question like this, R squared is 0.8566. And then interpret that 85.66% of the variation in the maximum temperature can be explained by the variation in the minimum temperature. So always in context. Same statement, but in context. All right. And again, be flexible. Make sure that when you read the question carefully and be flexible how you answer that. But this is a general direction that you should take, general sentence that you should make. And you can therefore write down the regression equation because I did not define a variable for maximum temperature and a variable for minimum temperature, so therefore I'm just using just y hat equals to 1.1721x plus 7.9648. Or you can actually write down something like max temp equals to 1721 mean temp plus 7.9648. All right. The reason I don't do that is very hard to write ahead there. So I use y unless I define a variable. If you define a variable, that's fine. And if you can look at the plot as well. And if the question asks if this is appropriate, always say yes or no. You must answer yes or no. Yes, this is an appropriate model due to the high R² value. 85.66% of the variation between the variables is explained. Now, generally, when we look at how you answer the question, this is a tip. Do you agree or do you not agree with the statement? Always say yes and then give the justification. All right? If you say yes and the justification is not correct, you still get 1 point. If you don't say anything, yes or no, if you don't answer the question, just give the justification. If it is wrong, and that's it. The whole thing is wrong. So make sure that you always answer the question. And always in context. Tomorrow when I go through the test, there are one question in particular that a lot of you did not put it in context. We'll talk about it tomorrow. All right? Context is very important. All right, let's go to the next example, please. All right, data was collected by a maths teacher to investigate the relationship between student test marks and the number of hours spent studying for the test. The collected data is displayed in the table below where the test mark has been recorded as percentages. So you know that the test mark is percentages, but you can still put in number. In the exam itself, just put in a number. So you need to be able to identify the explanatory and the response variable. That is quite common. One of the common questions that they will ask. View on your calculator or computer. Of course, in the exam, it's calculator. The scatter plot of this data and describe the relationship between the values. All right. When you describe it in terms of strength, the direction, and strength, direction, and what is the other one? Can you remember? I can't remember the third one, but we'll talk about it in a few minutes. And then determine the value of coefficient to 4 decimal places. Interpret, give the equation, and then is the linear regression model found in E appropriate for this data set. All right, you need to be able to justify your answer. Hey, both of you, what are you doing? All right, if you've done it, the explanatory variable is the number of hours of study, and the response variable is test mark. Now, view on your calculator or computer the scatter plot. If you've done it correctly, it's something like this. That's what I did. So the three things that you need to actually talk about is the form, the direction, and the strength. All right? Describe the relationship. How would you describe that? So it's a strong, positive, linear relationship. Form is linear, direction is positive, strength is strong. You can see that it's really strong because all this data point nearly falls right on that line of best fit. So now you should be able to determine the value of the coefficient of determination. So R squared is 0.9093. That is really strong. 9093, that's really strong. Remember, when you have 4 decimal places, you are only looking at the 5th number. If it is below 4 and below, round down. 5 and above, round up. All right? So 481, 9093, 481, you round it down to 9093. All right? So now R squared is 0.9093. And then interpret the coefficient of determination. So it's 90.93% of the variation in the test mark, in the bracket percentage, can be explained by the variation in the number of hours of study. So this is how you use that sentence. Once you've done that, you can use predicted test mark equals to 8.3208 times number of hours studies plus 19.88. This is what you have. I should have written down 19.8756. All right, that's my fault. I ran out of space for that. So remember, you could use predicted test mark and number of hours studies, or you can use T and H. Is up to you. 19.88 8756. All right, 4 decimal places. And F is this linear regression model found in E appropriate for the data set. Justify your answer. So always answer yes, the regression model is appropriate because it is a strong positive linear relationship with the high R square of 19.97. Then I explained that only 9.07% of the variation between the variable is unexplained by the model. Just because I want something which is slightly different from P. All right? So here we're talking about coefficient of determination. So therefore, when you answer, you got to answer the coefficient of determination, not correlation coefficient. All right. Now, the note that you need to know is R squared equals to R times R. So therefore, if you are given R, you should be able to find R squared, which is just squaring of that number, that's all. All right? So now, if R squared is given, you can find R. The only issue is when we have R squared equals to, for example, 0.49, we don't know whether R is positive or negative. That's the issue there. So, to determine whether R is positive or negative, you need a scatter plot so that you can see that the direction is positive or negative, or the regression line equation. The regression line equation will be able to tell you whether it's positive or negative. All right, so the last example, we're going to go through this. The correlation coefficient of a set of bivariate data is 0.61. Find the coefficient of determination as a percentage. So you want it as a percentage, and then you have R squared, you need to find R. So part 1, you need your calculator. So R will be 0.61 squared, which is I need my calculator as well. .61 times 0.61. That gives me 0.3721. Now, part B. Is this positive or negative? If you look at the equation, so y equals to mx plus c. So think about this form as y equals to c plus mx or mx plus c. So m is a gradient, that is positive. So therefore, if you know that the coefficient r squared is 0.92, r is, because this is positive square root 0.92, which is, or actually that should be in percentage, 37.21%. Square root of 0.92. .9592. All right. So read. If you're given the least square equation, you know that it's positive. Therefore, r is positive. All right. If not, you don't know whether r is positive or negative. You can only use the regression line equation or the graph. All right. Happy with it? Now this is what I want to talk to you about today, which is all on coefficient of determination, r squared. We're concentrating on r squared. Now, in the actual assessment itself, you'll be asked to find r and r squared, and then you have to talk about both r and r squared. All right? At this stage, for this one, we are talking about r squared only. All right? You should be able to derive coefficient of determination, r squared, from the coefficient of correlation and vice versa. Use class pad and interpret the coefficient of determination. So basically the sentence I gave you is what is important. All right, I'm going to stop here. There should be enough exercises in club for all of you to do. And plus one request is I've put up a pivot link if you could do the pivot survey for me. Thank you.